Hi children. In the previous class, we discussed about area of a sector and segment of a circle. In this section, we will discuss some problems from exercise 12.2. See the question. The length of the minute hand of a clock is 10 centimeter. Find the area swept by the minute hand in 5 minutes. So, in this clock, this is representing a minute hand. The length of the minute hand is given 10 centimeter. That means that is the radius of the circle. What is the area swept by the minute hand in 5 minutes? So after 5 minutes, the minute hand will be here. That means you can mark it the position of 1 and 2. So when it is after 5 minutes, it will be here. The minute hand will be here. So what is the area of this portion? That means that will be a sector of a circle. This is the radius of the circle, and this is also the radius of the circle. So the portion enclosed between two radii and the corresponding arc is known as the sector of the circle. That means you want to find the area of this sector. To find the area of the sector, first of all, you want to know the angle of a sector. Here we know that angle described by the minute hand in 1 hour. Angle described by the minute hand in 1 hour. That means it's 60 minutes. Angle described by the minute hand in 60 minutes or in 1 hour, that will be equal to 360 degree. Then what will be the angle described in 1 minute? We want to find it 5 minutes. What will be the angle in 1 minute? Angle described by the minute hand in 1 hour or 60 minutes is equal to 360 degree. Then what is the angle described by the minute hand in 1 minute? That is equal to in 1 hour, that is means in 60 minutes 360 degree angle. Then for 1 minute it will be 360 by 60, that is equal to 6 degree. In 1 minute, the angle described by the minute hand in 1 minute is equal to 6 degree. Then what will be therefore the angle described by the minute hand in 5 minutes? That is equal to 1 minute it is 6 degree, then for 5 minutes 5 into 6 degree, that is equal to 30 degree. In 1 minute, 1 hour or in 60 minutes the angle will be 360 degree, then for 1 minute it will be 6 degree, then for 5 minutes it will be 5 into 6, that is 30 degree. So after 5 minutes, or the angle of this sector will be equal to 30 degree. We know that if after the angle between these two radii, that is 30, then when it is reached at the number 2, it will be 30 plus 30, 60, and when it is at 3, it will be 30 plus 30 plus 30 will come, so 90 degree. Total angle is 90 degree. That means the circle is divided into 4 equal parts. This is 1/4 of the circle. So angle in a quadrant or angle in a quadrant equal to 90 degree. So here we don't need to find the 15 minutes, we need only 5 minutes. So the angle described by the minute hand in 5 minutes is equal to 30 degree. Now we are able to, if you know the angle and the radius of the sector, we are able to find the area of a sector. So area of a sector served by the minute hand is equal to area served by the minute hand is equal to theta by 360 into pi r square. We know the angle and we know the radius, so we can find the area. That is equal to 30 by 360 into pi r square. Pi value you can substitute 3.14 into radius. Radius of the circle, or radius of the sector is equal to 10 centimeter. That means 10 r square, that is 10 square. That is equal to 1 by 12 into 3.14 into 100. That is equal to 3.14 into 100 is 340. If you multiply by 100, the decimal place will move to the right side. So 314 divided by 12, that is equal to 26.1 centimeter square. So area served by the minute hand in 5 minutes is equal to 26.1 centimeter square. Let us see the next question. A horse is tied to a peg at one corner of a square-shaped grass field outside 15 meter by means of a 5 meter long rope. Find the area of that part of the field in which the horse can graze, and also find the increase in the grazing area if the rope were 10 meter long instead of 5 meter. In this question, it's given it's a square-shaped field and a horse is tied one corner of this square-shaped field. So let the horse be tied at the point O. Then the length of the rope is OH. Length of the rope is OH. So when you can see that the horse is grazed this much area, that means you can see a sector shape in that field. This is the area, this much area the horse is grazed. We want to find the area of that field. The area, thus the area of the field in which the horse grazed, that will be equal to the area of this sector or area of this quadrant, because the angle of the sector is equal to 90 degree because it is a square shaped field. The angle of the square is 90 degree. So this is a quadrant of a circle with the angle 90 degree. And OH, that is the length of the rope, that will be 5 meter is given for you. This is also equal to, because it's a circular shape, it's a quadrant of a circle, so these are the radii of the sector. So radius of the sector is 5 meter and the angle of the sector is 90 degrees. So very easily we can find the area of this sector. So area of the field grazed by the horse is equal to, that means the area of a sector. Area of the sector, that is equal to theta by 360 into pi r square. So theta, that value, theta is equal to 90 degree. 90 by 360 into pi r square. Pi value you can substitute 3.14 or 22 by 7. Anyone you can use it. Into r square. Radius is equal to 5. So 5 square. Now 90 by 360, that is equal to 1 by 4. So we are getting area of this, we know that area of a quadrant is equal to 1/4 of the area of a circle. So 90 by 360, that is 1 by 4 into 3.14 into 5 square, that is 25. That is equal to, when you multiply this is equal to, you are getting 19.625. 19.625 meter square. Because the length of the rope is equal to 5 meters, so the area you are getting 19.625 meter square. That will be the area of the sector. That means the area of the field or area of the part of the field the horse can race. The second question, what is the increasing area? Instead of 5 meter, if the length of the rope is equal to 10 meter, what will be the area, or what is the increase in this area? If the length of the rope is increased to 10 meter, then it can raise this much area. Is it? So this length is equal to, length of the rope is equal to 10 meter. If it is 10 meter, what will be the area? First of all, we want to find out if the length of the rope is equal to 10 meter, what will be the area? Then we can find the increased area. That means this is the increased area. So when the length of the rope, or when the radius is equal to 10 meter, that means when the length of the rope is changed to 5 meter to 10 meter, the radius will be changed. The radius of that new sector. Radius of the new sector is equal to 10 meter, and the angle of the sector is same, it is 90 degree. So area of the new area is equal to 90 by 360 into 3.14 into r square, that is 10 square. That is equal to 1 by 4 into 3.14 into 100. That is equal to 314 by 4. That is equal to 78.5 meter square. So the new area is equal to 78.5 meter square. The area of the first field is, when it is when the radius is 5 meter, you are getting the area this much. If the radius is increased, or if the length of the rope is increased, then the area will be 78.5 meter square. We want to find the increasing area. The area increased by, that means the increased area. So that is equal to, we want to subtract increasing area. Increasing grace area is equal to, when it is 10 meter, it will be 78.5 meter square, minus, when it is 5 meter, it will be 19.625. That is equal to 58.875 meter square. So increase area, that means this area will be equal to 58.875 meter square. A brooch is made with a silver wire in the form of a circle with the diameter 35 mm. The wire is also used in making 5 diameters, which divide the circle into 10 equal sectors as shown in the figure. Find the total length of the silver wire required and the area of each sector of the brooch. So the diameter is equal to 35 mm and the radius is equal to 35 by 2 mm. And we want, for your first question, find the total length of the silver wire. So the total length of the silver wire used is equal to circumference of the circle of radius 35 by 2 plus 5 diameters. So circumference of the circle is 2 pi r plus 5 diameters. Length of the 5 diameter. Length of 1 diameter is equal to 35 millimeters. So 5 diameters, 5 into 35. So 2 into 22 by 7 or 3.14 into radius. Radius is equal to 35 by 2 plus 5 into 35. Here 7 and 35, the 7 is the common factor, so 5 sevens are 35, and here 1 2 is 2, 11 twos are 22. So 2 into 11 into 5 plus 5 into 35, that is equal to 285 millimeters. The total length of the silver wire is equal to 285 millimeters. So we got the first question answer. Total length of the silver wire used in that object. The second question is, the area of each sector, that circle is divided into 10 equal sectors. So what is the area of each sector? Area of each sector. We know that area, the whole area of the circle is pi r square, that time the whole angle, that center angle of the sector is 360 degree. That circle is divided into 10 equal sectors. So if it is divided 10 equal sectors, the angle of each sector will be 360 by 10. So angle of each sector. Angle of each sector is equal to 360 by 10, that is equal to 36 degree. 36, the angle of each sector is equal to 36 degree. So if we know the angle and the radius, we know the radius of the sector and now we know the angle of each sector. So we can find the area of each sector. So area of a sector or area of the sector is equal to beta by 360 into pi r square, that is equal to angle is 36 divided by 360 into 3.14 into radius. Radius is equal to 35 by 2 whole square. So you can better use it here 22 by 7, then it will be cancelled. Then that is equal to here 36 by 360, that is 1 by 10. So 1 by 10 into pi r square, 1/10 of the whole area of the circle. 3.14 into 35 by 2 into 35 by 2, or you can multiply 35 by 2 whole square. That is equal to 385 by 4 millimeter square. When you multiply this, you will get 385 by 4 millimeter square. So area of each sector is equal to 385 by 4 millimeter square. So today we discussed 3 problems. You should note down these problems in your notebook and practice it well. And today's your worksheet is exercise 12.2, question number 3 and question number 10. And few questions we will do it later in this exercise. I like question number 7. We will do it later because we need the basic knowledge of trigonometry. So that questions we will do it later. You have to practice these questions, study well. Thank you.